Why very limited attendance is there? Okay. So today we are going to discuss about the membrane fouling. So last class we discussed in membrane some terminology is there. Sometime we can see that on the basis of flux, pressure difference, we can calculate the rejection rate and other things. The next associated problem with the membrane is a membrane fouling, and it is one of the common problem in membrane. And because of this fouling problem, still membrane is a not good choice for the wastewater treatment. In drinking water, it is a quite a good option, but in wastewater, still it is not a good choice because of this membrane foul. So this term fouling, why this, when to use and how to use? Actually, it's describe the potential deposition and accumulated of constituents in the feed stream of the membrane. So what happened? Why it is not this membrane process? Why it is not good in case of uh, wastewater? Because in wastewater the constituents is quite high, and because of that there may be more chance of the membrane falling. Next is, so why it is important to study, because when we are going to design an operation of membrane system, we have to calculate the chance of the membrane falling. Because of that, on the basis of that, we are going to design the backwashing. Because on the basis of that, we are going to identify the degree of pre-treatment. What is the meaning of here degree of treatment? So if we are going to pass the water, wastewater from a particular membrane, and if we able to know the membrane chances of the membrane falling, so we are going to do pre-treatment so that we can actually decrease the chances of membrane falling. So this design operation of membrane system is directly going to affect by pre-treatment, cleaning requirement, operation condition, cost and performance. So all this thing is directly affected by this design and operation of the membrane system. So now that's why what happened, why pre-treatment is required. So whether you are going to treat the water, if I am talking about wastewater, so whether you are this wastewater is biologically treated or chemically treated, because if it is a biologically treated, its constituents is going to be different. If it is a chemically treated, it is their constituents is going to be different, and in both cases there will be different types of the following that we are going to discuss here. So falling of membrane can occur in the three general form. Number one, buildup of constituents in the feed water on the membrane surface. So on the membrane surface, when buildup of constituents occur, there may be one chance or one form, the formation of chemical precipitate. Why this chemical precipitate? Because if pre-treated water have some chemical component. Third form of the membrane fouling may be damage to the membrane due to presence of chemical substances. So if chemical substances is there, so if biological agent on the surface of membrane, if biological constituents is there and this chemical is going to test, then there may be chance that it is going to create the fouling problem. So there may be three chances of the fouling. So this is the, in previous slide we can say that this is the general form of the fouling of the membrane. But what are the mechanism behind this uh, membrane fouling? Why? Because membrane fouling means accumulation of something in front of the membrane, number one, or within the pore, or some layer is going to form. So that's why it may be pore narrowing, it may be pore plugging or gel cake formation. So there may be three chances. So what will happen when and how it is going to form? So when I'm talking about cake and gel formation caused by, so how it is going to cake and gel in filtration system, when we in our previous classes, I think wastewater treatment as well as the water supply engineering. In filtration system, the very common word used is mud ball. So what is the significance of that mud ball? Actually, mud ball define the whether backwashing is required or not. Mud ball on the surface of the filter represent the means the degree of backwashing or frequency of backwashing. We can identify this thing. So same thing if cake gel formation is there on the surface of membrane. So how it is occur? It is because it is the concentration polarization, and when it is going to occur when the majority of the solid matter in the feed water, means the water which is going to treat by that membrane, is larger than the pore size or molecular weight cutoff of the membrane. So if it is, this is the pore size of the membrane, and if it is more than this thing, then we can say that cake gel formation is going to be occur. Or concentration polarization can be described how other way we can describe is that it is a buildup of matter close to or surface of the membrane. So when it is going to this buildup of the matter, so what will happen? Actually, it is going to increase the resistance to the solvent transport across the membrane. So pressure is going to be, we need more and more pressure. So what will happen? Rejection rate is going to increase. So this formation of gel or cake is extreme case of concentration polarization. When it is going to happen? When extreme case means now first what will happen? First their pore is going to be blocked. After that their surface is going to block. Then this gel cake formation is going to occur. So where a large amount of matter is deposited in the membrane surface forming a cake layer. So now we understand what is the pore narrowing, pore plugging and gel cake formation. It is going to be more clear when we are going to discuss with the figure. So this is three figure: pore narrowing, pore plugging, and gel formation. You just see here. So it's well known gel formation is there. And what will happen? A cake type formation, not gel. We can say that, especially we can say that it is a cake type formation is there. In pore plugging cap, the size of pore and the size of the constituents in the feed water, if they are in same size, it is going to block. Sometime what happen? It's a narrowing. Narrowing means like this thing, a road is there, then people started to construction their house near the road. So after some time, they are going to take care of this places, and then we actually the road is narrowing now. So same thing applicable here. So if feed water have a constituents and the during this pores, this constituent is going to deposit on this surface, and that because of that pore is now narrowing, and what will happen again? Rejection rate is going to increase. So these are the concept the mechanism involved in the membrane fouling. So the mechanism of pore blocking and pore narrowing will occur only when the solid matter in the feed water is smaller than the pore size or molecular weight cutoff. Very simple. Number two, pore blocking occurs, this one, when the particle become stuck in the pores of the membrane, if same size or less than this thing. Pore narrowing occur when any solid material gets attached to the interior surface of the pore. So these are the example of the, we can say the mechanism during the fouling of the membrane. So how we can control this fouling? So there are three methods by which we can control the membrane fouling. Number one is pre-treatment of feed water, membrane backwashing, chemical cleaning of the membrane. So this thing, because you know that this even in our actually most of the houses nowadays they have a portable water purifier system. In that water purifier system, this UF, MF, and RO system is there. So first, but you always going to be observed that they always put one external filter outside the filter unit. Can anybody tell what is the purpose of that filter unit? Have you observed that thing? In most of the cases, you will find that when this installation person come to our house for the installation of this thing, they always recommend that sir put one simple filter unit outside the filter unit. What is the purpose of that thing? To remove silt. Very good. To remove silt, to remove suspended impurities, actually to enhance the life of membrane. So this fouling is not going to be occur frequently. So this is one of the method. So based on that, we can say that same thing applicable to wastewater. In this, what we are going to do? We are going to do pre-treatment of feed water with a different technology available this thing, so that because this membrane treatment process belongs to post-treatment. So if it is a post-treatment, so our primary and secondary treatment should be good enough. If it is a good enough, so what will be going to happen? There will be less chance of the membrane falling. Now membrane back flushing. So like in our house, the membrane system is there. It is a cartridge filter. So here backwashing is not allowed. So here backwashing is not allowed. But if you are going to see membrane system in power plant, I have visited near to Dhanbad. There is a Mathan Power Limited. So just now they install RO system for their boiler, and they invested approximately 100 crore rupees for this thing. Now you can understand how much this big industry is there. They invested 100 crore rupees for the RO system for their boiler. Now you can imagine. So membrane black backwashing. So if they are going to invest 100 crore rupees for the boiler, so every time they are not going to change the membrane. So what will happen? There is a continuous backwashing system is there, so that they actually able to enhance the life of the membrane. Chemical cleaning of the membrane. So good example of the chemical cleaning of the membranes is generally if it is a inorganic based membrane, so we can use chemicals, acidic component for to remove the impurities. So what will happen? All the impurities is going to dissolve in that chemical, and the now membrane is going to be free from constituents, feed water constituents. So number one, pre-treatment is used to reduce the TSS and bacterial content of the feed water. This often the feed water be conditionally chemically to limit chemical precipitation within the units. This is very important, right? What is the meaning of this thing? Feed water will be conditions chemically to limit chemical precipitation within the units. So what will happen if your water, feed water have a chemical constituents, and if it is going to pass through the membrane, and if it have a reaction, if it is going to take a reaction, so that what will happen? It is going to if especially this membrane is an organic nature, then it is going to dissolve in that thing. So control that thing. We have to conditionally chemically to limit chemical precipitation. We have to idea whether their reaction will be there or not. Backwashing with air or water is the most common method. So because we know that only water is not sufficient, most time what we are going, we are mix the water and air, so that with less water we can clean more and more membrane. Chemical treatment is used to remove constituents that are not removed during conventional backwashing. So in conventional backwashing, what we are doing, air and water, and sometime because of their sometimes this constituents in feed water have a sticky nature, and we are not able to remove with the simple back flushing. In that aspect, we need a chemical. So what will happen? That sticky item is going to dissolve in that chemical, and then we can easily remove that constituents from the membrane. So this is the control method of the membrane fouling. So what is the how to assess whether pre-treatment is required or not? Number one, if required, how much is required? Whether we can use RO, or RO plus UF is required, or UF plus MF plus RO is required. That we have to take care. So to assess that treatability of whatever wastewater, drinking water, whatever the thing is there. If why here NF is there? Because you will find that in most of the cases, efficiency of NF and RO is almost same. So there must be, we have to idea at which time this membrane fouling is going to occur. If we are going to pass the water with 10%, 5% or 5 milligram per liter sill, then we can say that, this fouling is going to occur after 1 year. Then it's okay. But if we have idea now, what will be the concentration of this thing? Who is going to decide? If water have this much limit, then there is no need of pre-treatment. So that's why fouling index was developed. The purpose of this thing, based on that, we can identify the types of treatment and degree of pre-treatment. So 3 principal indexes were developed. The name itself is, number one is SDI, that is a sill density index. Second one is modified fouling index, MFI. And third one is mini plugging factor index. So the purpose of all index is, simple thing is, just to identify the fouling index. Based on that, we are going to identify the best treatment. So in this, how we are going to calculate this index? In this thing, we are going to pass the water through millipore filter. You know, this is very common filter used in laboratory, especially in water laboratory. So we are going to pass the water through this millipore filter with a size of 0.45 micrometer, with a 47 mm diameter, and with the 210 kilopascal, to determine any of this index. So what will happen? How same experiment, with the same experiment, how we can get a different type of index? So here what will happen? We can get a different type of index based on the time and data collection time. Means the experimental time and data collection of time. So because this test varies from 15 minutes to 2 hours, so based on that, we are going to calculate this thing. So if we are going to calculate SDI is nothing, it is 100 minus 1 minus TI upon TF divided by total time. So it is a total time of test. TI is time to collect initial sample and final sample. So TI, TF, it is going to be more clear when we are going to solve numerical. So here what happened? The silt index is a static measurement of resistance that is determined by sample taken at the beginning and its after action. So we are going to pass the water through this millipore filter. So what will happen? Initial concentration is going to be different and final concentration is going to be different, but natural, because you are passing the water through a filter. So this SDI test does not measure the rate of change of resistance during the test. So what will be the limit of this SDI value? How to know whether pre-treatment is required? This is going to be more clear from this table. So if you are going to pass the water through nanofiltration or reverse osmosis, reverse osmosis, hollow fiber, spiral bonded. We already discussed what are the hollow fibers and what are the spiral bonded. So SDI, if it is between 0 to 2 or 0 to 3, then in that case, we can say that there is no pre-treatment is required. Now, You just see. So, and another method is modified following index is also going to determine using the same equipment, same procedure, but the volume is recorded every 30 seconds over a 15 minutes. In previous case, what we did, we are going to take only 2 reading. Here we need a number of reading. So derived from a consideration cake filtration. So 1 upon Q A MFI plus P. MIP is modified following index, second per liter square, volume, constant, average flow liter per second. So based on this formula, we can easily calculate. Now, here it is a index. When it is an index, so how you are going to find out this thing? Because in previous slide, it is very clear how to calculate this thing. So what will happen? We are going to draw a curve, this curve, through throughput volume and inverse flow. So what will happen? You will find this data with reference time, volume. So here second per liter and here liter. So you'll find that the slope of this region, because here curve is there, so we are not going to consider. Slope of this region is nothing, it is MFI. So here 4 minus 1.5 divided by 12 minus 2. So nothing, it is a 0.25 liter per second. So if it is within this range, we can say that there is no need of pre-treatment. So one numerical, try to solve it. So determine the silt density index for a proposed feed water from the following data. Total runtime is this thing. Initial 500 ml, we are able to get 2 minutes, and final 500 ml 10 minutes. So what will be the value? 2.67. So what is the meaning of here 2.67? It's very clear. It's very simple formula. That's why I'm not explaining here. So what is the meaning of 2.67? The meaning of this 2.67, because here I'm talking about a spiral bound RO membrane. In spiral bound RO treatment, if HDI value is 0, in between 0 to 3, in that case, there is no need of any pre-treatment. Now, water we can easily treat with that thing, or we can say that what conventional pre-treatment system is there, that is more than sufficient. There is no need of additional pre-treatment. Next, so this is application of various membrane technology. So now one student, only 26 student is there. Anybody interested to explain first one, aerobic biological treatment, in their own language? If anybody is interested, just I want your participation. That's why I'm doing like that. If otherwise, I can tell. If anybody want, he or she can explain this line. Application description. Okay, I'm ready. So, typical application of membrane technology in wastewater treatment. So, aerobic biological membrane. Here, what will it go? It is a biological and aerobic treatment. So here, when membrane is going to be, in this case, membrane is used to separate the treated wastewater from the active biomass. Because it is a biological treatment system. Biological, how we are going to achieve biological treatment system? With the help of biomass. So after the treatment, we have to separate out both the things. So we can separate out both the things with the help of membrane. Anaerobic biological treatment, same, membrane is used to separate the treated wastewater from the active biomass. Membrane aeration biological treatment, again, aeration biological. So whether it is aerobic or aeration biological treatment, more or less we can say that same thing is there. And here again, whatever the biomass attached to the outside of the membrane, that we have to take care. Membrane extraction biological treatment, pre-treatment for effective disinfection. So these are the general requirement. So when I'm talking about disinfection, so where this membrane is going to use when pre-treatment of effective disinfection. So what will happen? Just to remove residual suspended solid from the secondary effluents or the effluent from depth of the surface to it. So what will happen? Otherwise, if you are not going to remove this suspended solid, so chlorination or UV is not going to be effective. Pre-treatment for nanofiltration and reverse osmosis. So if you are going to, especially this is applicable for, can anybody tell? Last two is applicable in case of, last two is applicable in case of drinking water. So in drinking water, there is or we can say that 1, 2, 3, 4, 5, 6. So 6 is especially for the drinking water, and 5th is common drinking water as well as wastewater. So 6 microfilters are used to remove residual chloride and suspended solid. If you are not going to remove colloidal and suspended impurities, then what will happen? This RO is not going to be work effectively. So this is the common application of microfiltration and ultrafiltration technology. Nanofiltration, when and where to use. So effluent reuse, what happened many times we need to reuse the water, especially nowadays. Most of the thermal power plant and other industries, they have zero discharge concept. Means ministry already informed that you cannot discharge a single liter of water outside the premise of your industry. In that case, they have to reuse that effluent. So nanofiltration is one of the good choice for that thing. So used to treat pre-filtered effluent, typically with microfilter for indirect portable reuse application, such as groundwater injection. Sometimes what happened? Now ministry told that you cannot discharge that water. Then what you are going? You are going to do that water harvesting. How you are going to achieve? You cannot inject that water into groundwater without treatment. So what will happen? So first you are going to use microfiltration followed by nanofiltration. Wastewater softening, again, their application is quite common. Reverse osmosis, again reuse. Just now I have given example. In Madan Power Limited, they use the RO system because in their boiler, what happened, the excess water is recirculated, and then for the reuse of that water, they use this RO system. Effluent dispersal, reverse osmosis have a proof capable of removing sizable amount of selected compound. Two-stage treatment for boiler use, I already discussed. So application of membrane technology for the removal of specific constituents. So biodegradable organics. So except microfiltration, we can remove all these things. Hardness, only NOF and RO. Why? Because it is most of the time it is ions, and MF and UF is not able to remove the ions. So because heavy metal is again example of ions, nitrate is again example of iron, whereas organic pollutant is able to remove by pollutants. Synthetic organics, TDS. So TDS is nothing, it is a representation of different ions. TSS can be easily removed by this thing. So why, whether TSS cannot be removed with the NF and RO? No, it can be removed, but the problem is that if water have a TSS, you cannot feed that water directly to NF or RO. In that case, this is required. You need to pre-treat that water with the help of MF and UF. So bacteria, all these things. But the virus can be removed only and only with the NF and R. So application of membrane technology. Now, typical characteristics of the membrane technology. So You just see this value. This value is very important. This value, this value, and this value. You'll find that initial range of this thing, microfiltration and ultrafiltration, flux rate is almost same. Their operating range in terms of the micrometer, you'll find that it is approximately 10 times less than this thing. But in case of water flux, it is not like that 10 times. And that's why ultrafiltration is one of the popular choice. Now nanofiltration, again, you'll find that it is rate of flux means the rate of working is almost good, and it efficiency is, you can again say that 20 times. Reverse osmosis, it is 10 times of the nanofiltration, but you'll find that their rate of flux is one of the slowest, we can say that, and their range is very narrow. Now membrane detail, most of the time it is cellular and polyamides. Okay, configuration we already tell what is spiral, hollow, thin film composite. These are the common example of this thing. Energy, because the ultimate the purpose of any water treatment research is to find out a suitable method which is going to require a minimum energy. And you will find that nowadays people are why they are working on electrodialysis. Their efficiency is as much as good. Their recovery is as much as close to nanofiltration. But here energy consumption is at least less than RO. Even it is more than the nanofiltration, but still it is good than RO system. And that's why it is quite popular nowadays, and still researchers they are trying to reduce the energy consumption in electrodialysis. Previously CDI, captive deionization, FCDI. These are the flow captive deionization. So these are the example of the electrodialysis nowadays researcher is working just to reduce the energy consumption. Advantages and disadvantages. So advantage, what are the advantages? It's 5:40. Please rejoin the meeting. So you people please write down attendance. Actually today I'm not feeling well. I have some problem. So next Friday class, I'm going to complete this membrane session. And anybody have any doubt here, you can ask. So next week probably, because some classes was missed when I was out of the station. So I think that was 3 classes. Is it I'm right?
Yes, sir.
So next week I am going to conduct 6 classes. So 3 classes may be video lecture and 3 classes I am going to take care by myself. So be ready for, because next week Tuesday your classes is going to be scheduled as per the scheduled time, that is I think 5 to 6. So you people are free from 6 to 7.
Yes, sir.
Yes, sir.
Then there will be continuous 2 classes. There will be continuous 2 class on Tuesday. Then Wednesday again 7 to 8 and Friday again 7 to 8. Okay, then in that case, Tuesday, Wednesday, I'm going to upload in I'm going to upload in Google Class. Extra classes, and every day it will be 7 to 8. Monday,
Okay,
Tuesday,
sir.
Wednesday, whatever. Okay. Those who had given attendance, they can leave the meeting.
Sir,
Yeah.
sir, previously you had told that for drinking water, we don't need to do RO, it's unnecessary. But here in one of the slides, we saw that while comparing all the treatment methods, the last 2 methods, one of the method was RO, and you said that for drinking water, we will use it.
I told that time, most of the time it is a useless. It is not like that every time it is useless. If your water have a TDS only 200, 300 milligram per liter, then there is no need to do this RO system. If your water did not have any heavy metal, only this TDS is 200, 300, then there is no